Welcome to a new Voltlog. Today we have an interesting piece of gear on the workbench. This is the Micsig MHO1 series, the newest tablet form factor 12-bit oscilloscope from Micsig. So this is considered their 6th generation and comes with a bunch of improvements over previous generations while keeping the user interface pretty similar. So if you've used a Micsig before, this should feel familiar. I did have one of their previous gen tablet scopes. I believe it was the STO1004, which was considered Gen 4, and indeed this one feels very familiar, but with a few very important improvements. So what we have here is the MHO14-200, which basically tells you this is the 4-channel 200 MHz bandwidth with integrated multimeter. Now this is available as a 100 MHz version as well, and both the 100 and 200 MHz versions can be had with or without the integrated multimeter capability. By far, what I consider to be the most important upgrade in this newest generation is the new 12-bit vertical resolution, which is now becoming a standard in the industry, even for these budget-friendly scopes. But there is more. A real-time sampling rate of 1 gigasamples per second, a storage depth of 110 megpoints with maximum waveform capture rate of 50,000 waveforms per second, all in this thin battery-powered 3.1 centimeter tablet form factor. The screen is an 8-inch high-definition anti-glare finish with a resolution of 1280 by 800 pixels, and of course capacitive touch, and you will appreciate this anti-glare finish while working in the field. Another big selling point, at least for those seeking that, is that this model now comes with an optional integrated 4.5-digit multimeter. But before I dive deeper into the features and specifications of this scope, let me mention that Micsig has sent the scope for free for the purpose of this review, but they're not paying me and I'm free to say anything I want about the scope. Also, if you're looking to get one and you are in the EU, I recommend checking out evision-instruments.com. They're based in Germany. I got my unit shipped by them. They're super friendly and professional, and they've agreed to offer a 5% discount code for my viewers, which you'll find in the description below, so definitely check them out. Continuing with the specs, the internal battery is a whopping 16 amp hour long life lithium ion battery, which Micsig says can last 1000 charge-discharge cycles, which is double that of most normal good batteries can handle. Now charging is done via the included 12 volts 5 amps barrel jack charger, but can also be done via a USB Type-C port, which is located on the back. That's very convenient, especially for field usage, to keep the machine running for longer by connecting an external power bank. The standard runtime of this scope is quoted as up to 4 hours, so I wanted to see what I would obtain. I ran a test with 2 of 4 channels active, measuring the test signal provided on the back. The screen was set to 80% brightness, ambient temperature 25 degrees Celsius. The fan was running throughout the entire test period, and I got 2 hours and 18 minutes, which is lower than what I was expecting. I was probably expecting something over 3 hours. Now, whether 2 hours is enough for you to do your field work, it's up to you to decide, but keep in mind that you can easily extend that with a power bank. For me, that 3 to 4 hour runtime would have been nice to have on the built-in battery. I then measured the charging current over the 12 volt barrel jack input, and it was drawing around 2.3 amps at 28 watts total peak. And that's surprising because I thought this was going to be a higher current since the provided adapter is rated for up to 5 amps. I also tried the USB-C charging with a Lenovo laptop adapter, and it negotiated to 9 volts, drawing approximately 20 watts. But by switching to this compact VoltMe 45 watts USB Type-C charger, it negotiated to 12 volts, drawing approximately 25 watts. So I don't really see any benefit to using the DC barrel jack charging method, as it shouldn't be any faster. Charging on the 12 volt barrel jack, took 2 hours and 15 minutes. though I don't expect this to be any different on the USB-C port given a proper adapter is used. I just haven't run the same test on the USB-C. Another important change over previous generations is the new rotary knobs over older joysticks used for the user input on previous gen. First of all, no professional engineer is going to enjoy operating an oscilloscope just by using a touchscreen. Real engineers need real knobs, and while the previous generation joysticks were okay, slightly better than a touchscreen, they certainly were not ideal, and I would always prefer proper rotary knobs on top of those. Now on this newer gen we get nice high quality rotary knobs, which I certainly appreciate. They make my life easier whenever I need to use the scope. They can all be pressed for like a 50% setting, and the general feel of the enclosure is, you know, that of a high quality ruggedized tablet. Maybe not as rugged as the previous generation, which had thicker padding on the sides, but still ruggedized due to this softer rubber padding which goes all around the edges. The total weight of the unit is 1.7 kilograms, and the I/O connectors have all been moved to the back, keeping the sides clean now. You still get this nice beefy carry handle, but since it's no longer located on the side as with the previous gen, which you could just slide your hand like this, now you need to like balance it on your arm, something like this, which is going to end up touching the screen. So I don't know, the carry handle may be less ideal when it's placed at the top. On the back we notice the main DC charging jack with a little recessed switch beneath that for a main, which is acting as a main power lock. Now that feature is good. It prevents your scope from accidentally turning off while being carried on. However, the size, the diameter of that switch makes it like impossible to press with bare fingers, and it's also too small, for example, for the DC jack to be used to activate that switch. So you really need to have something pointy like a thin pen to push that, or maybe use the multimeter or scope probe, but I feel like that may damage your scope probe, so probably best not to do that. Now, the test signal output is also located near the DC charging port. There are a few cooling vents, and this one is for the cooling fan on the back. Now I noticed that the fan is under software control, so it can completely turn off at times when the scope is cool enough, but that rarely happens in practice, because once you start running the scope and it gets to temperature, the fan is always on. Though it doesn't have a bad whine, it sounds similar to a laptop that's running an intensive task with like CPU at 100%. And looking through these vents, I can see that this looks like one of those nicer cooling fans which have their fins spaced at different intervals to spread the noise spectrum. So that's nice attention to detail, but still it's a small cooling fan. Of course, now putting a bigger cooling fan would have meant less noise, but also it would have meant that you needed to have larger vent holes on the back, which would have allowed water and dust to get inside the scope. We also get an RJ45 Ethernet jack for network connection and an HDMI version 1.4 output, which is useful for connecting to an external monitor. And there's also this one USB 3.0 Type A port, which can act as USB host. And I had this populated with the Wi-Fi adapter. I just realized that, and we'll talk about this in a few minutes. And there is the USB Type-C port, which can act as USB device and also accept charging via PD negotiation. There is a built-in 32 gigabytes of internal storage, so you wouldn't really need to connect any external storage. You can just save screenshots and screen recordings to the built-in memory. This Gen 6 scope does not come with built-in Wi-Fi, which is a bummer because we used to have that on the previous Gen 4 tablet model, and it was capable of using that right away to pull updates directly from the internet or connect to your local network. It does, however, support a USB Wi-Fi dongle, and Micsig does offer an official one, and I found this picture online on some Chinese websites, but I think these are harder to get or they're going to be more expensive than mainstream dongles. So to save you the trouble, I tested these 5 different adapters to let you know which one works and which doesn't, because these are available on pretty much any big distributor like Amazon. Now I have one that looks identical to the so-called Micsig official with the green logo. It says driver free on the box. I have another one in a similar package but with an orange logo. And I also got this Mercusys AC650 adapter, and I already had these two TP-Link adapters. They're both model WL725N, but there are slightly different revisions, and these are the ones that were supported by the Rigel oscilloscope. Now, long story short, the one I had the most hopes for, the green logo, doesn't work. It's not detected. The similar shaped but orange logo one is detected and works. The TP-Link dongles, the WL725N, they both work. The silver one is an older revision. The gold one is a newer revision. And the Mercusys dongle also worked fine. Now, since these TP-Link adapters can be purchased for under $10, available from multiple sources, they're very compact, they're supported by other instruments, I would probably recommend getting one of these if you want to add the Wi-Fi capability. On the back, we also have the similar folding tilting feet as previous gen, and down here there is a little cover which is covering a 10 amp fuse. Now this is likely for the multimeter high current input, and let's check what type of fuse they have in here. I should probably mention that the latest revision of the user manual version 1.0 from April 2025 shows images of an automotive blade fuse, and included with the scope inside the accessory box I did found this spare 10 amp fuse, which is this compact automotive style blade fuse manufactured by PEC/Yazaki, and this is rated for 58 volts 10 amps. Now, PEC/Yazaki is a world-class fuse manufacturer, there's no problem with that, but this specific fuse is only rated for DC usage up to 58 volts. That's of course not up to multimeter standards, where the AC, higher voltages and sufficient energy might be present to ignite and maintain an arc on such a simple DC fuse. And unfortunately we do find that blade style fuse inside the scope, and a close-up of the fuse shows the same markings as the spare fuse included in the accessory box. And on top of that, to add to this confusion, now the user manual claims Cat 1 300 volts multimeter rating, but on the front of the scope it says right here that this is a Cat 2 1000 volt multimeter input. The only good thing that can be said about this is that this fuse cover does shroud the fuse all around, insulating it from any potential arcing or explosion that might happen with the fuse. In terms of what's included in the box, you get the 12 volts 5 amp charger included, complete with the wall socket cable. You get a set of test leads for the multimeter and 4 scope probes and the spare fuse, as well as some paperwork with a calibration certificate, which does mention the unique serial number on the scope, but there is no clarification whether this extends to the multimeter as well, or if it's just for the oscilloscope part. The included scope probes are model number P138. These are pretty standard and similar, if not identical, to previous Micsig probes I've had, but one important thing to note is that they are fixed times 10 probes, no adjustment switch, and the scope does allow you to set a different attenuation factor in the vertical menu, but you will need to provide your own X1 probe if you want to do that. One word of caution is to always remember to do the compensation adjustment on your new probes when you get like a new scope or probe delivery. I've seen many bad measurements due to uncompensated probes. Optionally, there are 2 storage cases available from Micsig. There's a soft carry bag with multiple pockets and a hard carry case similar to a Pelican case, which will give you the ultimate rugged protection for situations where you need to take your scope with you on that mountain hike and fix something in the middle of nowhere. In terms of the user interface, it's pretty good. It's very familiar if you've used a Micsig oscilloscope before. It's just a little better screen, a little more polished interface. The buttons work great, the rotary knobs work great too, and the touchscreen can be disabled by long pressing the home button. because I know some people might want to do that. It's very helpful that we have dedicated buttons for selecting each one of the 4 channels. We have dedicated controls for the vertical, for the horizontal, for the trigger section, and we can do quick swapping between the trigger channels using these arrow keys. There are these additional rotary knobs, number 1 and number 2, which can help when navigating the menus or the capture window while in zoom mode. There are dedicated buttons for enabling the horizontal or the vertical cursors. We also have dedicated buttons for opening the top and the bottom menu, and you are going to need these buttons occasionally. You can also swipe from the bottom or the top to open those menus using the touch screen. You are going to need opening these menus from time to time, because one of the actions that's actually hidden away and doesn't have a dedicated button is the screenshot, which is hidden inside the bottom menu. So that's how you do a screenshot. I would have liked to have like a dedicated screenshot button because that's an action that I typically use on my oscilloscope every time I need to use it. There is this quick save button, which is always present on the bottom bar, but this actually saves a waveform, not a screenshot. In my opinion, that's less useful to have always present on screen than the screenshot button. There's also a dedicated scope slash DMM button, which switches between the oscilloscope and the multimeter functionality. When you go back to scope mode, it will keep this little floating window with the multimeter measure that you left active. And the nice thing is that you can position this thing pretty much anywhere you want on screen, even on top of these top and bottom bars. Now let's have a quick look at some of the functions this scope is offering. First, and my favorite, when you purchase a Micsig, as far as I'm aware, you don't need to pay extra to get the serial decoders. They are included by default in the purchase. So with this particular model, you get a long list of available decoders like UART, LIN, CAN, CAN-FD, SPI, I2C, 429, 1553B, and it supports 2 decoding channels at the same time, and it also does ASCII decoding for like serial interfaces. And I've used this decoding capability on my previous Micsig tablet scope to debug more exotic UART interfaces like 9-bit or a 6-bit interface. So I really appreciate Micsig including these decoders by default and having this much flexibility. However, there are also a couple of quirks which I'd like to mention. For example, I do have this UART configured here, and let's do a quick single capture. Okay, so we have captured this window, and we can see that I have enabled a serial decoder to show the hex value and a second serial decoder to show the ASCII value for this capture, and it is connected to a UART TX port running at 115K baud rate. In fact, let me show you the configuration. This is a standard 8N serial port. But what I've noticed is that, for example, if I want to change the settings of this second S2 serial decoder to show me the hex values instead of the ASCII, it cannot do that on the fly on the already captured that data, but it should be possible to do that. Instead, I have to do a new capture for the new setting to apply. Also, I think it's not necessary to waste 2 decoder channels, one for ASCII, one for hex. I think it should be possible to enable both a hex view and an ASCII view when decoding a serial port on one single serial decoder channel, so you can have the second one free for decoding a second line, for example. Although granted, if you open the bottom menu, there is like a table view that you can use for this type of analyzing of the incoming data, and this will show you both hex and ASCII, and it gives you a better overview of what's coming in over that serial port. As with most modern DSOs, you get a 6-digit hardware frequency counter, which is nice to have. It doesn't come enabled by default, so what you really need to do is go into settings and enable the frequency counter. But what's even nicer, hides under the sample menu and is the segmented storage feature. Now this can be very powerful, particularly for analyzing intermittent or burst type signals. So instead of wasting the entire 110 megpoints memory on a single continuous capture, which may only contain just one or two of the events that you're looking for if they happen sporadically, the scope is capable of splitting that memory up to 10,000 smaller capture segments, and each segment capturing only when the trigger event occurs with a specific window, and there's all of this dead time between segments where no data is being stored. So now all of a sudden you can capture maybe 10,000 of your of the events that you were looking for instead of just one or two. And if you've ever used an oscilloscope to debug some intermittent signals, you have for sure observed the limitations of the memory and for sure wished you've had segmented memory capability. I sure did. Now this is a very powerful function which you don't usually get on entry-level scopes, but you get this with the MHO1 series. The scope can also do FFT and advanced math functions, and again I have used these before on Micsig, and because their list of math functions has always been pretty comprehensive, you can even create your own expression of the math that you want to run between a couple of channels. However, a couple of notes here: FFT waveform does not support automatic parameter measurement, meaning it can't automatically place markers and snap to points and get your measurements automatically. Generally speaking, the FFT is handled in software, and I don't think there is a dedicated FPGA or DSP to run the FFT, so your results may vary. It may be useful for educational purposes, but maybe not so much for those that need proper FFTs with measurements, especially as the frequency goes up. Now let's quickly go through the multimeter functionality. This is a pretty standard 4.5 digit auto-ranging multimeter. There is a big reading display at the top. There's a chart display in the middle with some history, and then there's measurement selections on the bottom side. The big advantage of having this big display is that you can fit a lot of stuff. For example, you can have the mean, max, and average values always on. You can have a big measurement display and a graph in the middle all at the same time. The multimeter probes that come with the included with the meter, they feel pretty standard but decent, nothing wrong with them. They will get the job done. The input jacks are easily accessible on the front with standard 19mm spacing. There doesn't seem to be any jack detection, so this coupled with the underrated fuse can potentially be problematic if you don't watch where you plug the jacks in. In terms of the buttons that we have here, they're all basically disabled while in DMM mode, so you can only select the different measurements by using the touch screen. The continuity beeper is latched and decently fast, but it could have been a little louder, especially for field usage. The update speed seems to be approximately 3 updates per second, 2.5, 3 updates per second maybe. The diode function does go up to 2 volts, which is okay, but I've seen better. It appears to have 2 functions defined for measuring resistance, either that or there's something I'm missing here, because there's this ohms symbol, but then there's this one which looks like a through-hole resistor. What I can conclude here is that there's clearly a lot of development happening in this area, as the UI that the user manual shows as screenshots is completely different than what I have here in the latest version of the firmware. So we'll probably see a few more updates coming in a future firmware update. Now, regarding remote view and control of the oscilloscope, both PC software and iOS/Android remote control apps are available, as well as standard Skippy commands. And in addition to that, if you connect it to your local network via wired or the Wi-Fi module, by accessing the IP address of the scope in a browser, you do get full control over the scope screen. Or you can just access the screenshots and screen recordings and download those. That's awesome, because it means you don't need to install a custom app. Just a browser will work nicely for most users and most tasks for remote viewing or controlling the scope, or just downloading the screenshots that are saved on the internal memory, so you don't need to connect physically with a cable to a computer, and I very much appreciate that. I also tried the iOS app and it works as long as you manually input the IP address and both the phone and the scope are connected to the same network. I guess I wish the app would have detected a Micsig scope present on the local network by itself. So I think I've played and used this scope enough in the past couple of weeks to have a good general overview of its capabilities. So let me share you the final thoughts on reviewing this oscilloscope. It's a well-built portable tablet format entry-level scope, and if you've had a Micsig before, this will feel very familiar but with very good improvements on top. I like the new glare-free LCD, the image is sharp and bright. I like that we have dedicated buttons for anything you could wish for except a dedicated screenshot button. The buttons are nice, high quality, the rotary encoders work perfectly to enable a smooth experience for operating the scope without getting in your way. The new segmented memory feature, coupled with the 12-bit vertical, the 200 MHz bandwidth and 100 megabytes of memory, makes this a very versatile tool for bench work and field work, especially considering the price. Its built-in serial decoding protocol support as well as comprehensive remote control capabilities is again a big plus for me. Yes, you have to provide your own USB Wi-Fi adapter, which is not ideal, but for a part that costs less than $10 and is available pretty much anywhere, I don't see that as a major issue. But it's not all perfect. I do have to mention that I'm not happy with the multimeter input protection, which is not up to the standard they claim in the manual, Cat 1 300 volts, and certainly not up to Cat 2 1000 volts. But if you don't need a multimeter inside your scope, then you can just opt to get the model without the built-in multimeter and save another 90 euros or so off your purchase price. So overall, this is what I would just get, the 200 MHz version without the built-in multimeter, and I would also use the discount code provided in the description to reduce the price even further. The runtime on battery is also a little bit misleading because they quote up to 4 hours in the datasheet, but in reality you get like 2 hours and 20 minutes at best under regular usage conditions. But again, I don't see that as a major limiting factor as long as you are aware of the real number from the start. You can just expand that as needed by using a USB Type-C power bank. Now to conclude, this is a well-built, modern 12-bit oscilloscope and I'm quite happy and lucky to have it, but what do you think? Have you had a chance to play with one of these newer gen tablet oscilloscopes? Let me know in the comments below, and if you're interested in getting one, don't forget to check out eVision Instruments and the discount code provided in the description below. That was all for today. Thank you for watching and I'll see you soon.